Hello everyone, me, your friend Krishna Kumar Chaudhary came with the chapter. Today we will study about the chapter that is mean value theorem. Mean value theorem. Okay, the chapter is our mean value theorem. Now, and under it we do have some of the theorems. The first theorem we will study about it, that is the Rolle's theorem. Rolle's theorem. Rolle's theorem. Oh. So let's study the statement for if a function. What is the statement of this Rolle's theorem? If a function fx is, first condition is continuous in closed interval, that closed interval say lower point is A and upper point is B. No, in AB, continuous in AB. Second is differentiable in open interval, differentiable in open interval that you have AB. And third condition is FA is equal to FB and FA is equal to FB. No? Then there exists one C. Okay, then there exists one C, we can say point, no, one point C in between A and B, anywhere in within A and B. Okay, such that the derivative f dash c at that point will be the 0. This is your Rolle's theorem. If the function is continuous in a AB, differentiable in open interval AB, FA is equal to FB, then within A and B there will be the one point, such type of point, such that f dash c will be there 0. No, so proof of this. Suppose that function is continuous. No, suppose, since given what you have given, if a function is, what is given there, function is continuous. Since function, what you have given, function fx is continuous where? In closed interval AB. No, and we know that if a function is continuous, it may attain the maximum and minimum value. No, so there obviously there will be the point that will give us maximum and minimum value. Since function fx is continuous in AB, so there exists C and D in AB such that at C point you will get M, capital M, and that M is your, say that this M, you can say it the maximum value of fx, the maximum value of fx. And at D point, say you are getting the minimum value, say fd is equal to a small m, the minimum value of fx. No, fx. Okay, since function is continuous, due to the continuous, it may attain it has a maximum and minimum value. Say that maximum value is capital M and minimum value is small m. Maximum value attain at point C and minimum value attain at point D. Okay, now let's come to the conditions. First case, suppose if maximum value and minimum value are equal, if m is equal to a small m, that is the maximum value value is equal to minimum value. No, minimum value. No, maximum value is equal to minimum value. Then obviously the function will be the constant function. Then function is constant function. No, everywhere obviously if you will get the same value, the function is called constant function. Is constant in that interval AB. Suppose in that interval, no, AB, then function is constant, and function constant due to constant function, the constant function has always derivative 0. So the constant function derivative is 0. Constant function derivative is 0. Derivative is 0. What does it mean? That means f dash x equal to 0. No, for all x in a comma b. That means if there will be the c point, f dash c is equal to, that is f dash c is equal to 0 for all c in a comma b. Now this is your first case when the maximum and minimum value will be the equal. Now maximum and minimum value will be equal. That whole criteria is depending upon the continuous. Okay, due to the continuity of a function, there has a maximum, the function attain a maximum minimum value. Suppose that maximum value is capital M, as minimum value is a small m. Capital value, maximum value attain at point C, and a small m, that is minimum value attain at point D. Suppose this maximum and minimum value are equal. If this will be equal, then function is continuous function. Constant function. If the and we know that every constant function derivative is 0. So f dash c x equal to 0. That means f dash c will be also 0. No, for the point C in AB. Now let us take the condition that m is not equal to a small m. Let's take the condition for m is not equal to a small m. No, case 2. Case 2. If maximum value, that is capital M, is not equal to a small m, that is minimum value, then what will happen? Then if both will not be equal, then at least one of them is different from FA and FB. No, means if maximum minimum value attains and that will be not equal, no, both the maximum minimum value will not be equal, obviously this maximum or minimum will be, one of them is different from FA in points functional value FA and FB. Suppose that let this one of them is different from FA. Suppose that M is different from not equal to M is different from FA. No, M is different from FA. No, and we need to show that. What we need to show that? We need to show that f dash c is equal to 0 for C belongs to AB. This we need to show. Suppose M is different, one of them will be different from FA and FB. Suppose M is that different, okay, M is different from FA and FA. No, then at point C, at x equal to C, what will be the right hand derivative? Right hand derivative means right of that function point. At point C, right side, you will get limit h tends to 0 by definition fc plus h minus fc and by h. No, this is the definition of right hand limit, which is equal to limit h tends to 0 fc plus h and minus fc. What is the function value of fc? Obviously it has the maximum value m and by h, and any maximum value, any functional value is subtracted from the maximum value, obviously you will get negative value, and this is your positive value h greater than 0. No, which negative divided by positive, obviously less Negative will be or will be 0 for what? For h greater than 0. This is say condition 1. And what will be the left hand limit? Left hand limit will be by definition limit h tends to 0 f c minus h, left side of that maximum value, that point, left side. Okay, suppose this is your m, no, c point where you have a m value, maximum value, or you can say which is equal to fc. No, then obviously this side will be the point fc plus h, no, and this side will be the fc minus h, and this is your maximum minus any functional value, minus fc and divided by what? Minus h. That is limit h tends to 0, no, fc minus h, and it has the value, maximum value, minus h. That you obviously you will get the negative of in the numerator, and denominator already you have negative. No, negative divided by negative, obviously you will get greater or equal to 0, positive will be. No, for what? For h greater than 0. This is the second condition. No, and after this, but what is the given? Given is that since function is differentiable, given what is? Since function is differentiable, we know that function is already given differentiable. Function is differentiable. No, it is given there. If part in the statement, differentiable. Function is differentiable means what? Differentiable in a b. What does it mean? That means what? That means f dash x exists. Okay, f dash x exists in a b. No, when it will be exist? Obviously f dash x exists means what? Right hand derivative will be equal to left hand derivative. No, and this will be possible only if, and this is possible. When it will be possible? Possible only if obviously there will not be a greater or less. No, there will not be a greater and less. Now that means must be equal to 0. Only when right hand derivative equal to left hand derivative equal to 0. Hence, what does it mean? Derivative f dash c is equal to 0. No, for c belongs to a comma b. Now this is the second part. And similarly case 3, suppose fd is different from fa. Now that you see. Case 3, if a small m is different from fa and fb, different from fa and fb, and what you let fd is different from fv, you can say, or fa. If suppose this, then in similar way we can show that what? So that f dash d is equal to 0. No, with d in a comma b. This completes the proof. This completes the proof. Okay, now let's talk about the geometrical meaning. What do you mean about it geometrically? So geometrical meaning. Okay, geometrical meaning. Geometrically, it obviously derivatives gives the slope, and slope means what? Tangent. Then Rolle's theorem gives, by Rolle's theorem, the meaning of the geometrical meaning of the geometrical meaning of Rolle's theorem is that the tangent parallel to x-axis. Theorem. The geometrical meaning of Rolle's theorem is the tangent parallel to x-axis. It will show the parallel to x-axis. No? Geometrically what it will show? It will show that it will give the tangent. Such type of tangent it will give, that will be the parallel to x-axis. No? Now let's come to the one problem. Okay. Let us talk about one problem. Suppose one of the question we can discuss it. Question is your verify Rolle's theorem. Verify Rolle's theorem. Rolle's theorem for fx you have given x square in -1, you need to verify. Okay, this is your question. So solution for this, obviously you need to check whether it is continuous or not, whether it is differentiable or not, f is equal to fb being or not, no, whether that point lies within the AB or not, that you need to check. So first is you need to check for continuity. For continuity you are going to check it. No, continuity you are going to check it, whether the function is continuous or not. Since fx equal to x square is a polynomial function. What type of function is that? Polynomial function. Polynomial function. And we know that as every polynomial functions are continuous. We know that every polynomial functions are continuous. So given fx is equal to x square is your what? Continuous. Where? Continuous in closed interval -1, 1. That first part is condition satisfied for the Rolle's theorem. No? And second condition is for differentiability. Whether it is differentiable or not, that you should check. No, this you need to check it for differentiability. And we have by the function, for the function, what will be the f dash x? First derivative of fx will be your 2x. That is fx is differentiable. That is, this function fx is differentiable. Any point you will give, that will exist. Differentiable where? -1, 1 in open interval. No? And you need to check third condition, that fa is equal to fb. Whether the in points functional value are equal or not. For that, obviously fa, a means lower limit, this one, -1 you need to check. What will be the -1 of a square, which is equal to 1. f1 you need to check, 1 of a square, which is equal to 1. Keep the values in function here. What you got? Since f minus, therefore f minus 1 is equal to f1. This condition also satisfied. No. Now what does the Rolle's theorem says? If all the conditions satisfies, then it says there exists, therefore, or you can say therefore you need to check the C point. Therefore by Rolle's theorem there exists C belongs to -1, 1, such that obviously f dash c is equal to 0. No, f dash c means what? F dash x, you had what you had, that is f dash x, what you had? 2x. No, f dash x you had 2x. So f dash c, just substitute here c, then you will get 2c. 2c is equal to 0. What you will obtain? C is equal to 0. Does the c, this point 0 lies within the -1 to 1? Thus Rolle's theorem verified. No, thus Rolle's theorem verified. All the conditions satisfied. Rolle's theorem verified. In this way you can verify, okay, Rolle's theorem. And next question again, question for this question: can Rolle's theorem be verified to a function? Can Rolle's theorem, next question is, theorem be verified to the function fx is equal to log x. You need to check in what, -2, 2, whether the function, can Rolle's theorem be verified or applied in these functions. So what will be your answers? Obviously for the negative of this logarithm, no, you can say the given function is not continuous. The given positive would be then continuous, no, interval would be positive then continuous. The given function is not continuous, no, is not continuous for negative value of x. Negative value of x, okay, negative value of x. Thus Rolle's theorem cannot be applied, no, because function first condition is not satisfied. Why to go further, no, differentiable, I need to check f is equal to fb. The given function is not continuous for negative value of x. Thus Rolle's theorem is cannot be applied, okay. And in this way you can, and similarly I would like to give the questions. One, if fx is equal to x plus 1 by x is a function, if this is a function defined on an interval, on an interval, the interval you have given 2, 1 by 2, 1 by 2, 2, no, interval you have given 1 by 2, 2, so that Rolle's theorem can be applied and find C, C belongs 1 by 2, 2, okay. You check it yourself, you can complete it, okay. And this much, no, you complete yourself. The function, obviously the function is continuous, no, x plus 1 by x case, here function is continuous. This is a rational function, and obviously if it would be the interval 0 less, no, 0 including 0 minus negative even, here would be the negative or 0, then the function will be discontinuous, would be discontinuous for that interval. But here 1 by 2 and positive onward, I think function is continuous. No, function is continuous. You can check the differentiability whether it is continuous or differentiable or not. Then you can check fa is equal to fb whether it is equal or not. Then you can find the value of c in the similar pattern, this pattern. Okay, thank you. This much for today.